Hello, fellas. How are you doing, guys?
Hello,
Halo
Fadly.
Fadli.
I'm doing fine. Are you in Palembang?
Yes, I'm in Palembang. What about you, Ray and Bianca?
I am in Jogja. I ate a lot of gudeg on Eid Mubarak's day. I also felt delighted last Tuesday because Mr. Dai has celebrated Halal Bihalal in our class, right?
Yes, I'm still on my house in Jantung City, Lee. Yes, true. Last Halal Bihalal was actually part of building our consciousness for others. Here, I got a video from our CC session with Mr. Dai. Do you guys want to check it out?
Well, of course, it will be very nice for us to see our friends performing in front of us. Please share your screen to us, okay?
Yes.
Okay.
Dan kau hadir merubah segalanya.
Ayo yang lain dong, yang goyang-goyang dong yang lain.
Lebih
Wow. These voices
Wow.
are amazing, right?
Yeah, that was very good by you all. I'm
Wow.
very delighted by it. Okay, so
Okay.
I think it's time to move on to our task right now.
Good morning, evening, or afternoon, class. My name is Bianca Natasha, and today my group will present about finite element analysis, or FEA, onto the trusses.
Hello friends, my name is Mochammad Fadly.
My name is Mochammad Reyhananda Setiawan. Okay.
So in this presentation we will have 4 main content. The first one is a problem, and then we go to the flowchart, then we go to the coding, and the last one is the conclusion. The problem. So there is a trusses. The member of the truss shown in the accompanying figure have a cross-sectional area of 10 cm square and are made of steel. The E value is 200 GPa. Using hand calculation, determine the deflection of each joint, the stress in each member, and the reaction force. Verify your results.
Okay, thank you, Fadli, for stating the problem. And next slide, please. Okay, now I'm going to explain the flowchart to find displacement into the truss by FEA, or finite element analysis. So as you can see in the screen, there is a main flowchart in the left side of the presentation. And this main flowchart is actually made by these 3 blue flowcharts, or we can name it as a function flowchart. There are 3 function flowcharts here. The first one is stiffness matrix flowchart. The second one is local global flowchart. And the last one is Gauss-Jordan flowchart. So to start the flowchart, we should input parameters and geometry, A, E, F, L, and the angle. And then we will find the stiffness matrices and the errors. And then next, we will change the stiffness matrices into local stiffness matrices. Then we will add all of this local stiffness matrix, so it will be a global stiffness matrix. Next, we will apply boundary conditions, and then we will find the displacement using Gauss-Jordan method, and then we will get the output displacement and end the flowchart. Moving on to the function flowchart, the first one is the stiffness matrix flowchart. We will start the flowchart, and then we will input the angles, solve the stiffness matrix, find the error, and end the flowchart. For the local global flowchart, we will start the flowchart, and then we will input the stiffness matrix, point connected, and end, and then we will applicate the initial zero matrix and transform stiffness matrix into global matrix, and then end the flowchart. And the last flowchart, or the function flowchart, is the Gauss-Jordan flowchart. We will start the flowchart, and then we will input G initial, X, and N, and then solve it using Gauss-Jordan, and then eliminate the float error and end the flowchart.
Okay, the next part is the coding part. So this is actually how we're gonna code in the Open Modelica software. As you can see here, this is the parameter and the initial condition. There is an N, A, E, and the initial condition is the global matrix, the global displacement, the solution matrix, and the X matrix. And also we're going to set the boundary condition, which is the B1 and B2. And B1 is equals to 1 and B2 is equals to 3. Also, because we're going to calculate the trusses, so we need to list all the parameter of each of the trusses. There's truss 1, truss 2, truss 3, truss 4, and truss 5. As you can see here, is the parameter and the initial condition also. And then after we list all the parameter and the initial condition, we're going to move to create the global matrices. The first one before we create the global matrices, we need to obtain the stiffness matrix. How do we obtain the stiffness matrix? This is the code of the stiffness matrix function. The first one, always remember that we need to input our parameters to the function, and then we start the algorithm. And this is the algorithm of the stiffness matrix. It's a little bit long, but you'll get used to it. Okay, and then the last one, we're going to look the matrix, the stiffness matrix that we obtained from the algorithm to get the float error. And then after we get the float error, we end the function, we end the stiffness matrix function. Okay, after we obtain all of the stiffness matrix function, we're going to make the local global function or local stiffness matrix. Okay, how do we obtain the local stiffness matrix? This is the algorithm. This is the code for the local global function. The first one, you need to input all of the parameters, and then we're going to look for the matrix, the stiffness matrix. After we look the stiffness matrix, we're going to make the calculation to obtain our local stiffness matrix. It's also a little bit long and confusing, but if you really wanted to know a little bit more, you can ask me or ask your friends maybe. Okay, so after we get the local global function or the local stiffness matrix, we need to sum all of the local stiffness matrix to get our global matrix. As you can see here, I set the G as the global matrix, and the G1, G2, G3, and G4 and G5 is the local stiffness matrix, and we sum all of the local matrix to get our global matrix. And then we set the matrix initial zero matrix as G initial. And then after we get our global matrix and we set the G initial zero matrix, we implement our boundary condition, or we apply the boundary condition. As you can see here, I look the matrix. As you can see here, this is the B1 and B2, which is we have already listed before. And then after we look our boundary condition to our global matrix, we also calculate the boundary condition to get our global matrix that have been implemented the boundary condition. And then after we get the global matrix, we need to solve the displacement with Gauss-Jordan, because the idea is to search for the displacement of our trusses, right? Now, the algorithm of the Gauss-Jordan function is we need to input all the parameters also, and then we define the float error as 10 power minus 10, and then the algorithm, this is the algorithm. We use a function in C language. The function calls modelica.matrices.solve A point B, and then after we get the X matrix, we need to find the float error, and then I look the matrix, and then after we get the float error, we end the Gauss-Jordan function, and then we obtain our displacement. And then after we get the displacement, the code is done. Okay, I think maybe you guys feels like it was really confusing and it was really hard, but yeah, we learn it by doing, right? Okay, the next.
All right, thank you so much, Ray, for the explanation from the code section. And from now on, I will take over to explain what is the conclusion of our task today. Please go on to the slide. Okay, so as we can see here, we have graphs that shows the displacement of the trusses that we analyzed in the previous section. So as you can see, the displacement, it's peaked on the 3 seconds, and then it goes back to its initial condition, and then the displacement continues to increase. And then as we can see from the previous section, I will conclude the step by step for looking the displacement in the 2D trusses cases. So from the start, we must input the parameter and the geometry. It is A, E, F, L, and the angle. And then we must look for the stiffness matrix and the error. And then the next one, we must change the stiffness matrices into the local stiffness matrices. And then we must add all of the local stiffness matrices, so it became a global stiffness matrices. And then we must apply boundary condition, and then look for displacement with Gauss-Jordan method. And then we will have displacement as our output from the algorithm. So I think that's all for the conclusion for our task. And in this slide, as we can see, there is sayings to remind us to stay conscious. Like Mr. Dai always say and remind us, consciousness is a very important thing in our life, especially for a student like us. We must do our tasks, do our homeworks, do our classes with a full conscious. So the task is became useful for us. What do you think, Bianca or Ray?
I agree with you, Fadly.
I agree with you also, Fadly.
Okay, so I think that's all from us. Don't forget to stay conscious, friends. Bye-bye.
Bye.
Stay healthy.
Thank you so much.
Thanks so much, guys.